Alright, we're going to work on the disk method. And the volume, when you do the disk method, the integral as x goes from a to b of, I guess I'll call it the radius squared times dx. Of course, if we do it with respect to y, then it won't be x going from a to b, it'll be y going from a to b, and we'll have dx here, and 1 minus hypo is pi times the radius squared dx. So we want to revolve the following area. This area here, we want to revolve it around the x-axis. That is, we're spinning around the x-axis. And the equation of this line segment, or line, is y equals negative x plus 1. So I want you to picture this little rectangle being revolved around the x-axis. And what it's going to become is a disk. It's going to be a circle with thickness. The area of the circle is pi r squared times the thickness. There's your dx. So what we need to do is find the radius. And the radius is going to be the distance from where you're revolving to the top of the piece that you're revolving. You're revolving around x, and the radius is going all the way to the top. The radius is just y in our case. So the volume is going to be pi times the radius squared dx, and the radius is negative x plus 1, the radius squared, and it's going from 0 to 1. So we go from 0 to 1, and we get pi times, if I FOIL that out, for example, I'll get x squared minus 2x plus 1 dx. From 0 to 1, and if I integrate, we get x cubed over 3 minus x squared plus x. And this goes from 0 to 1. And when you plug in 1, you get 1 cubed, which is 1 over 3, minus 1 squared, which is 1, plus 1. And when you plug in 0, you get 0, minus 0. Coincidentally, that cancels out, and what you get is pi times a third, or pi over 3. And that's the volume of that disk. If you revolve all of this area around the x-axis, the area would be, the volume will be pi over 3. Now when x is 0, this height is 1. Well, if you think about it, if you revolve this around the x-axis, what you're going to get is a cone. You're going to get a cone. Let me draw it somewhere, and let's see if our answer even makes sense. So, if you're given this problem on an exam, for example, you don't even have to use calculus. You can say, oh, I'm going to get a cone. I'm going to get something that looks like this. And this will be the equivalent of the x-axis. So basically, the height of the cone is from 0 to 1, so we know the height is 1, and the radius is that piece, which is the same as that, which is also 1. So r is 1. And the volume of a cone is pi r squared h over 3. And if r and h are 1, you get pi over 3. So you didn't even have to use calculus to get pi over 3. But it's a good check. If you're in teacher try that again. If your teacher insisted that you use calculus, well then you should still do what I did at the end as a check. Make sure you get the right answer. Here's another problem. You have y is equal to 4 minus x squared. And you don't want to revolve all of it, just part of it. You want to revolve this piece here around the x-axis. This must be 2 and that must be 4. So you want to revolve this area around the x-axis. First thing you should do is try using the disk method. I know that's what dissection is, but let's suppose there's also something called the shell method. You should always try the disk method, in my opinion. Put a little rectangle in here. As long as you know the height of that rectangle, it's the highest value minus the lowest value, which is 0. The height here is 4 minus x squared, and the height there on the bottom is 0. So the height, or the radius, is 4 minus x squared. That's the radius. So we're done. V is equal to the integral from 0 to 2 of pi times r squared. And I do have one typo, sorry. The original function, oh actually there is no typo, sorry. So it's pi times r squared dx. Well, let's square it. If you square 4 minus x squared, you get 16 minus 8x squared plus x to the 4th. Work it out. Make sure I'm right. Dx. And when you integrate that up here, you get pi times integral of 16 is 16x minus 8x, make the new power 1 more, divide by that number, make the new power 1 more, divide by that number. And we're going from 0 to 2. Since each term has an x in the numerator, when you plug in 0, you're going to get 0. So we just need to plug in 2. 16 times 2, 32. 2 cubed is 8, times another 8 is 664 over 3. 2 to the 5th, I think, is 32 over 5. What I would do is I would factor out 32. 32 and the pi was always there. So you have 1 minus 2 over 3. 64 is 2 times 32. When I factored out the 32, the 2 survives. You factor out 32 from 32 fifths, you just get a fifth. Okay, now we need to get a common denominator, which will be 15. 1 is 15 over 15, minus, multiply top and bottom by 5, you get 10 over 15. I already factored out the over 15. Plus, if you multiply top and bottom by 3, you'll get 3 over 15. And what's inside those brackets looks to me to be 8. So 32 times 8 sounds like 256 times the pi. Okay, that's not working out. So you get 256 pi over 15. This number in here is just 8. 8 times 32 pi is 256 pi. And there's the answer. 256 pi divided by the number 15. Pi r squared, the integral of pi r squared dx, or pi r squared dy. Okay, let's try this one. We want to revolve the area that's in between y equals x squared and y equals x cubed. the area that's in between. We want to revolve that around the x-axis. Here is x cubed. And x squared. And they meet at 1. Okay, this was all, say, given, but we can figure it out. If x squared equals x cubed, you bring everything to the right-hand side. You bring the x squared over, equals 0. You factor out x squared. You get x minus 1 equals 0. So either x squared is 0, which means x is 1, or x minus 1 is 0, which means x is 1. 1 minus 1 is 0. So they intersect at 0 and 1. So we want to revolve the area in between the two curves around the x-axis. Okay, let's try to make this picture a little bit bigger by doing the following. Okay. One curve is x squared, one curve is x cubed. The x cubed is the lower one. So now you put your rectangle. The problem is that we're revolving around the x-axis and the rectangle doesn't go down that far. So what we're going to do is we're going to actually extend it all the way down. And then when we revolve it, we're finding the volume generated by revolving what's in that red region that I just highlighted. And then we're going to take away this little piece on the bottom. We're going to take away what volume we get when we rotate that. So that's going to be our strategy. It's going to be a subtraction. So it's the integral from 0 to 1 of the big one. It's x squared. It's pi times the radius, which is x squared. Sorry. Squared dx minus, now from 0 to 1 times pi, we take away the little one. We take away the piece below this. We take away this piece here, the volume generated from that piece. And the radius is just x cubed. So it's pi times the radius squared dx. So we have pi times, this is x to the 4th. The integral of that is x to the 5 over 5 from 0 to 1 minus pi. This is really x to the 6th. So the integral would be x to the 1 more than 6 divided by that same number from 0 to 1. And you can actually factor out pi from the whole mess. You can factor out pi, and when you plug in 1 and 0, you'll just get 1/5 in that case, minus, and when you plug in 1 and 0 here, you just get 1/7. It's a matter of calculating 1/5 minus the 7ths. Here's the constant pi, and we're going to write everything over 35. This number here is really 7 over 35. And that number is really 5 over 35. So it's 7 over 35 minus 5 over 35, which is 2 over 35, times the pi in front. Minus some silly error, there's your answer. This time you had to subtract. You find more than the volume that you wanted, and then you take away the part of the volume that you didn't want. Revolve the area that's bounded by the curve y equals 2 and y equals 4 minus x squared over 2. 4 minus x squared. Okay, let's have a graph of this. 4 minus x squared looks like that. And here's 4 up here, negative 2, positive 2, and y equals 2 looks like that. Here's your x-axis and the y-axis. Now, the volume, or the area that's trapped, is this area in here. It's trapped by those two curves. So that's what we are revolving. So let's clean this up a little bit. For example, we don't need this over here. And we don't even care about those x values anymore. So we're revolving the area bounded by those two curves, which is this. Now, it'd be real good if we knew those x values. So what you do is you set the y values equal, because the two curves, they have the same y values right there and right here. Okay, so if I take away 2 from both sides, I get 2 minus x squared is 0. If I bring this 2 to the other side. That means that must be 2. 2 minus 2 is 0. 2 minus 2 is 0. So x squared is 2. What do you square to get 2? The answer needs to be routine. What do you square to get that number? The answer is always the same format. It's plus or minus the square root of that number. So right here is negative the square root of 2, and right there is plus the square root of 2. Okay, now we're revolving around the x-axis. But there's a gap. The curve, the area we're revolving, does not come down to the x-axis. So what we're going to have to do first is revolve all of this around the x-axis. And then we are going to take away what we get when we revolve the line y equals 2 around the x-axis. That's going to be a cylinder. Okay, so let's do this. So the volume is pi times the integral from negative square root of 2 to 2 of r squared. Now, r squared, well, r is 4 minus x squared. Now, if you think about it, let's look at this down here, please. That's the x-axis. We have symmetry. Whatever we get when we revolve this around the x-axis, that's going to be equal to it. The left side is going to be the same volume as the right side. So rather than going from negative square root of 2 to 2, how about we just do the right half? How about we go from 0 to 2, and then whatever answer we get, we double it. By the way, dx. Okay. Now we need to take away the part we didn't want to include. We never really wanted to include that volume, so we have to take it away. It's pi times the integral from negative square root of 2 to square root of 2 of the radius dx. But the radius is always 2. After all, it's a straight line, a horizontal line. Okay, and if you want, you can say, you know what, I'm going to go from 0 to square root of 2, so I'm going to double my answer. Okay, so it turns out we can even factor out the 2 pi. We have 2 pi here and 2 pi here. So it's the integral from 0 to 2 of this, which is 16 minus 8x squared plus x to the 4th, minus, I factored out the 2 pi, so integral from 0 to 2 of 4. 2 squared is 4 dx. Now, since we're integrating this and that over the same values, the same x values, namely 0 to 2, I can actually do the arithmetic. That is, I can do this function minus that function. And it'll still be from 0 to 2. 16 take away 4 is 12. Don't forget to take away 8x squared and to add x to the 4th. So this is the integral this is the function we're going to integrate. And when we do integrate it, we get 12x minus 8x cubed over 3 plus x to the 5 over 5. And this goes from 0 to 2. The nice thing about having 0 is when you plug in 0, you're going to get 0. If you plugged in, I guess there's a typo there. If you plugged in -2, you wouldn't get 0. But the typo is these numbers were not 2, they were square root of 2. Sorry about that. These all should be square root of 2's. Square root of 2's. Okay, we need to erase the top, and then we will plug in square root of 2 and 0. And again, plugging in 0 is just going to give us 0. Okay, so hold on one more second. Okay, so now copying the last line over, we have 2 pi. At least copying over the first part. Now, instead of x, we plug in square root of 2. 12 times x minus 8 times x cubed over 3 plus x to the 5 over 5. Square root of 2. Okay. So this is 2 pi. 12 square root of 2. Now, square root of 2 cubed. Square root of 2 times square root of 2 times square root of 2. How much is that? What is square root of 2 cubed? Well, that's 2 times square root of 2. It's 2 times square root of 2. And we need to multiply it. We need to multiply square root of 2 cubed by 8 over 3. So we get 8 times square root of 2 cubed is 2 square root of 2 over this 3. We get 16 square root of 2 over 3 minus 16 square root of 2 over 3. Now we have to do square root of 2 5 times. That's 2 times another 2 is 4. 2 times 2 is 4 times square root of 2 over 5 plus 4 square root of 2 over 5. Okay, calculus is over. Let's clean up our answer, however. The algebra is not. First thing I can see is I can factor out 4 square root of 2's. I can factor out a 4 because 4 goes into 12, 16 and 4. And square root of 2 goes into square root of 2's. And so I clearly factored out the square root of 2. When I factor out the 4, I'll factor out 4 from 12, we get 3. 4 from this number will be 4 over 3. And 4 from this number will just give you the 1/5. Okay, 2 times 4 is 8 times square root of 2 times pi. Now we need to clean up what's inside the brackets. I'm going to write it all over 15. The first common multiple between 3 and 5 is 15. I multiply this number by 15 over 15. I get 45 over 15. And 45 over 15 is 3. Minus, I multiply top and bottom by 5. I get 20 over 15. Here I multiply top and bottom by 3, by 3. And I get 3 over 15. Okay, the over 15 I'll factor out in front. So this is a numerator. Probably should write pi in front of the square root of 2. And what's left in the brackets is 28. 45 minus 20 is 25, plus 3 more is 28. And the final answer will come from multiplying 8 by 28, which is 224, I think. It's 224 pi times square root of 2 over 15. That's the exact volume you would get if you rotated that area about their x-axis. So now we're going to start revolving around the y-axis. We're going to start revolving around the y-axis. Find the volume if you revolve this picture. Okay, that's y equals x squared, or at least part of it. And we only want to go up to the 0.24. Okay, so that's what we revolve around the y-axis. Well, what does that mean? That means that we put horizontal rectangles. That's dy, and that there is the radius. And the radius is what x is. This length is x. This equation says that x is the square root of y. If y equals x squared, then x is the square root of y. Okay, why is it not plus minus? The only reason is because all our x's along this portion of the curve are positive. So we do the same game. We integrate this time over y. Y goes from 0 to 4. The lowest rectangle has y equals 0, and the highest rectangle has y equals 4. And the volume is going to be pi times r squared dy. And if it's dy, what goes in there should only be y's. So, I mean, on one hand, I'm not disagreeing, this is x. That length is x. But another way in this problem to write x is square root of y. We square it like it tells us dy. And when you square the square root of y, you get y. dy from 0 to 4. You integrate that and you get y squared over 2 from 0 to 4. I'll factor out the pi. So you get 4 squared over 2 minus 0 squared over 2. This is 0. 16 over 2 is 8. Pi times 8 is 8 pi. So that's the volume you would get if you rotate around the y-axis. And the reason we're able to use the disk method is because I can always find that radius. For example, if I want to revolve this curve around the x-axis, I can't do it because I don't know the highest value and the lowest value. Let me think what that might be, please, what the equation might be. This will be x is y squared, and So it might be, let me think, it's going to be like something like x minus 2 is y minus 4 squared. So this equation might be x is equal to y minus 4 all squared plus 2. That's the equation. Now, the problem is, in order for you to find out how long this is, you're going to need to know what the y value is up there, and you're going to have to know what the y value is down here. The problem is that you may not be able to solve this equation for y. For example, if I just stick in another y, you won't be able to solve this equation for y. So then you're going to have to use the shell method. You should always try to use the disk method. Shell method is another method which will be in the next video. So I need to motivate how you tell which one to do. You should always try to use the disk method. And right now, you want to use the disk method to revolve the given region around the y-axis. And the equation of this curve is y is equal to the square root of 16 minus x squared, and we have those points. This here is the region we want to revolve around the y-axis. And that's given. You're given the picture. You want to revolve that region around the y-axis. Okay, so you draw your rectangle horizontal to their x-axis, or perpendicular to what you're revolving around. So there's your dy. What you need to know is how long this is. Well, clearly that's x. For example, here's x right here. How long is this? X. The thing is, it's going to be pi times the integral, and y is going from 0 to 4. The lowest rectangle has a y value of 0, and the highest rectangle will have a y value of 4. So it's pi times the radius squared dy. Like I said, the radius is x. But you can't integrate something that has x's with respect to y's. So you don't panic too much. What you need to do is rewrite x so it has y's in it. If I square both sides, I get y squared is 16 minus x squared. If I interchange those two, I'm trying to solve for x. I get x squared, 16 minus y squared. If I take the square root of both sides, I get x is plus or minus this. Now, it's not going to matter which sign you put in, because when you square it, it disappears. However, in our picture, in our region, x is always positive. So we'll just keep the positive. 16 minus y squared, the square root of that. Now when you square that, you just get 16 minus y squared dy. And you integrate that, you get 16y minus y cubed over 3 from 0 to 4. And when you plug in 4, you get 16 times 4 minus 4 cubed over 3. And when you plug in 0, you get 0. Now, it turns out that 16 times 4 is 64, and 4 cubed is 64. So I factor out the 64, and I get 1 minus the third, and I keep forgetting to write pi in front. Sorry about that. Coming up here, I have 64 pi, and 1 minus the third is 2/3. 64 pi times 3, 128 pi. I meant to say times 2. 64 times pi times 2 is 128 pi. Please don't forget to divide by 3. And there is the volume that you would get if you take this portion of a circle and revolve it around the y-axis. Now, if you want to think about this geometrically, you can get away with doing the whole problem. For example, if you squared both sides, you would get this. That is, you would get that. This is the equation of a circle. This here is the equation of, in our case, the right half of the top of a circle. Basically, what I'm getting at is, if you revolve this area around the y-axis, you'll get a hemisphere. You'll get half of a sphere. You'll get half of a sphere. Now let's see if we did this right. Our answer is right there. Let's make sure we're doing this right. The radius of our sphere is going to be 4. The radius of the sphere is going to be that distance. So the volume of a hemisphere, well, I'm just going to find the volume of a sphere and divide it by 2. The volume of a sphere is, only I knew, I think is pi r cubed over 3. Now, r is 4. So it's pi times 4 cubed over 3 times 2. I guess the volume of the sphere I'm saying is wrong. Let me look that up real quickly. It's 4/3 pi r cubed. Oh, okay. Sorry. It's 4/3 pi r cubed. So, there's a 4 in front is what I'm getting at. There's a 4 in front. Now, 2 goes into the 4 2 times. This is 64. When I multiply it by 2, I get 128. And then I multiply it by pi. And then I divide it by 3. And what do you know? I got the same answer. So, again, unless your teacher says you must use calculus, you can do this problem without it. You are going to have to, unlike me, you're going to have to remember the volume of the sphere and then divide it by 2 because you're only doing the top half. And then r is 4. That's all I did, is I plugged in 4 here. And the math worked out to 128 pi over 3. So you want these type of problems on your exam because you can check your answer, or you can just not use calculus at all. What do I mean by checking your answer? You can do exactly what I did using calculus, maybe because your teacher says you must use calculus, and then you can check it by using the formula for a volume of a sphere. Okay, how about we do this one? Find the volume of the solid generated by revolving the region bounded by the graphs of the given equation about the indicated line. So here are the equations. Y equals 2x squared, y equals 0, x equals 2, and you want to do it first around the y-axis. Revolve around the y-axis. Okay, so it's the area bounded by those 3 curves. The first curve is 2x squared. Here is your first curve, 2x squared. And the second curve is y equals 0, which happens to be the x-axis. And the next curve is x equals 2. Which happens to be, say, right here. Now, the question is, which area is tracked between these three curves? Between the red curve, the green curve, and the blue curve. And the answer is this region right here. It's that region right there. Okay, so now that I know what the region is, what I'm going to do is I'm going to say that x equals 2 is elsewhere. Because it didn't look like big enough an area for me to work with. Let's call that 2, not here. So this here is the volume that's trapped by the three curves. The blue curve, the red curve, and the green curve. You need to be able to do that. So we want to revolve this around the y-axis. In fact, let us first do it around the x-axis. So if we do it around the x-axis, we put a rectangle perpendicular to the x-axis, and the volume is going to be pi times the integral of r squared dx. And r is going from 0 to 2. I meant to say x is going from 0 to 2. What is the height of this rectangle? The height of that rectangle happens to just be y. And y, I would love to write using x's. Y is really 2x squared. So 2 squared is 4. I'll factor out the 4. And x squared squared is x to the 4. That is, this mess is 2 squared times x squared squared. It's 4x to the 4th. And I factored out the 4. dx from 0 to 2. When you integrate x to the 4th, you get x to the 5 over 5 from 0 to 2. I like to factor out the constant. In this case, it's 4 pi. Now, when you plug in 2 to the 5th is 32 over 5. And when you plug in 0, you get 0 to the 5th over 5, which is 0. And the final answer is going to be 128 pi over 5. 4 times 32 is 128. So that is exactly what you get when you revolve this region around the x-axis. This region being here. This region right here. Okay, but now for part B, we want to revolve it around the y-axis. Okay. So, since we want to revolve around the y-axis, we draw the rectangle perpendicular to the y. But we need to extend it. That is, first I'm going to revolve that big area. That is, I'm going to keep revolving rectangles like this. And then, and only then, I'm going to take away this, what I get when I revolve rectangles like this. Because the blue rectangle is giving me more than I want. Now, the blue rectangles, that is, when I revolve that big line, when I revolve 2x squared, when I revolve this around the y-axis, excuse me, I take that all back. When I revolve this line around the y-axis, it's going to be a cylinder. Now, the question is, what is this point right here? Because I need to know what y is going from. Well, that's when one y value, better known as 2x squared, equals another y value. Okay? Well, let me think for a moment. What I know the x value right here. I don't know the y value. What is that miss doing here? Excuse me. At that point, I know the x value because everywhere on that line, everywhere on this line, x is 2. So x is 2, and to find the y value, I do 2 times 2 squared, which is 8. That is, y is going to go from 0 to 8. We couldn't set the two y values equal to one another because I didn't have two y values. I had y equals 2x squared and x equals 2. That is, to be crystal clear, this curve was y equals 2x squared, and this curve was just y equals 2. I meant to say x equals 2. There were no y in that equation. So to find that point of intersection, I really couldn't just say, oh, set the two y's equal to one another. Why? There weren't two y's to set equal. Okay, nonetheless, I found the point of intersection. So first, I'm going to revolve those big blue long rectangles around the y-axis. So the volume is going to be pi times, we're integrating over y from 0 to 8, and the lengths of the rectangles, the blue rectangles, are always 2. It's always 2. 2 squared dy, excuse me. And now I'm going to take away pi times the integral from 0 to 8 of some r squared dy. Now I'm going to take away the red ones. Well, again, the lengths of the red ones are x. Y equals 2x squared means y over 2 is x squared, which means x is plus minus the square root of y over 2. Now, since our x's are always positive again, I'll keep the positive one. And that's what I put here, the square root of y over 2. Now, once again, I can factor out pi. So I get the integral from 0 to 8 of 2 squared, which is 4 dy, minus, I factored out the pi, integral 0 to 8 of y over 2 dy. And I'll integrate these. The integral of 4 dy is 4y, minus the integral of y over 2 is y squared over 2 times the 2 that was always in the bottom. 2 times 2 is 4. And we go from 0 to 8. And now when I plug in 8 in here, I get 32 minus. When I plug 8 in here, I get 8 times 8 over 4. Rather than doing the 8 times 8, I say 4 goes into 8 2 times. 2 times 8 is 16. And when I plug in 0, I get nothing. And it turns out that number is 16. Pi times 16 is the same as 16 pi. And that would be your answer. Okay, let's do one more. And this time, we will not revolve it around the x-axis or the y-axis, but rather another line. suppose you want to revolve the area bounded by the curves y equals square root of x, y equals 0, and x equals 4, and you want to do this, you want to revolve it about the line x equals 6. Okay, so let's find a region. Y equals square root of x, well, that goes this way. And y equals 0, well, that happens to be the x-axis. And x equals 4, well, for argument's sake, let's say that's 4. So here is r equals 4. And of course, the blue curve goes on forever. Which region is bounded by the green line, or the green curve, the blue curve, and the red curve? And I hope it's very, very clear that it's this region right here. Okay, and we would just love to revolve this area. So let's get rid of the pieces we really don't need. We want to revolve that region about the line x equals 6. So again, you have this little hole. You're going to have a hole in it. When you revolve what I highlighted with blue x's, when you revolve this area around the line x equals 6, you're going to have a hole in it. Okay, because you're not going to really have this volume. That means you're going to have to do a subtraction. First, we need to find the volume when we generate those big rectangles. And it's going to be pi times the integral. And let's see. Okay, so it's going to be a dy problem. So what we need to decide is, what's the lowest rectangle? Well, the lowest rectangle is going to come from 0. And the highest one is going to go up to this height that's right here. Well, I know the x value is 4. To find the y value, I take the square root of 4. So it goes up to 2. Now, the whole length is going to be, to find the length of anything horizontal, it's the right minus the left. If I ask you how long is it from 2 to 7, you're going to do 7 minus 2. Well, the right end point is 6, and the left end point, well, I know it lies on this curve. That means x is squaring both sides. That means x is y squared. It's 1x minus the other x. X is the square root, x is y squared. It's 1x value minus the other x value. The x value right here is 6. And the x value right here is is y squared. So it's 6 minus y squared dy. But that included volume that we didn't want. So we have to take away some volume. We have to take away pi times the integral from 0 to 2 of another radius squared dy. And those distances is going to be these pieces. It's going to be those pieces. And that's going to be 6 minus 4, every one of them, which is 2. And what we get, again, we can factor out the pi. So when I square that, integral from 0 to 2, 36 minus 12y squared plus y to the 4th dy minus, this is 4, minus the integral of 4 dy from 0 to 2. And what we get is 36y minus 12y cubed over 3, but 12 over 3 is 4, plus y to the 5 over 5 minus the integral of 4 dy, which is 4y. 36y minus 4y, you can just call that 32y. And we integrate this mess from 0 to 2. So plugging in 0 won't do anything. We just plug in 2. 32 times 2 is 64. 2 cubed is 8. 4 times 8, 32. 2 to the 5th is 32 over 5. I would factor out 32 in this problem with the pi already in front. You factor out 32 from here, you have 2 minus 32 from here, you have 1. 2 minus 1 is 1. And from here you have a fifth. 1 plus a fifth is 1 in the fifth. So the final answer is going to be 32 pi, I'm at the very top, times 1 1/5. But 1 1/5 is 6/5. And 32 times 6 is 192 pi over 5. And that would be the volume you would get if you revolved this region, not around the x-axis or the y-axis, but along the line x equals 6. Okay, and that completes the section on the disk method. Work these problems out. They're not as bad as they think. Remember, if you want a horizontal distance, it's the right end point minus the left end point. If you want a vertical distance, it's the top minus the bottom.